Back to more chemistry. We're on question 20 for the study guide. If you want one done on the study guide, just email me which one you want done and I'll do it. That is how I'm choosing these. These are requests. I would not willingly choose these. Not that you know what I mean. Anyway, number 20. So number 20 says a valid Lewis structure of the ones that I'm going to do cannot be drawn without violating the octet rule. So octet rule means that elements like to have 8 electrons per atom, no more, no less. So if it violates the octet rule when we draw it, because sometimes you got to violate it to draw it, there are exceptions, then that's the one we're looking for. So if you look at the answer key, you know that it's going to be D, SEF4. So we're going to do the other ones to prove that they do follow the octet rule. Ready? We're going to start with PO43 minus. So that's because that's the first one. P O O O O. So PO43 minus. Phosphorus has 5 valence electrons plus. Right here. PO43 minus. Oxygen has 6 times 4, and then plus another 3. That's a lot. So 8 plus 6 times 4 is 24. So that's going to equal 32. Yay! Anyway, we're just going to do single bonds at first. See if that works. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32. That works. Also works because phosphorus likes to form 3 or 5 bonds. When it forms 3 bonds, so when it's like this, it's going to have a +1 charge. It doesn't like having like this. It's annoyed, frankly. Anyway, so when it's like this, it's going to have a +1 charge. These oxygens are all going to have -1 charges. Yay them, because oxygen likes to form 2 bonds. It didn't form 2 bonds, so it's going to have these nice little charges like this. I'm going to actually erase this so I can make my... Anyway, so that's how we get this 3 minus up here, because 1 plus 1, that's -4 plus plus a positive 1, so you get -3. Nothing here violates the octet rule. This P has 8, 2, 4, 6, 8, and then all these oxygens have 8. So this one is in the clear. Yay! You see, most of these are just being able to draw draw Lewis structures. If you want me to make a video on just drawing Lewis structures, I can. Or you can watch the Organic Chemistry Tutor's video because his are really good. But if you want me to make one, I can. Anyway, the next one is SiF4. SiF4. Literally, anyway, why is it... Ugh! So, Si, I don't know what that is, 1 second, has 4, because it's right under the carbon, likes to form 4, has 4 valence electrons, plus fluorine, 7 times 4, that's 4 plus 28, it's going to equal 32 again, I think. Hopefully. So fluorine can only have 1 bond, so it has to look like this. Okay? Fluorine cannot have double bonds. It is physically impossible. It's not going to work. Fluorine can only have 1 bond. So, and which is great because Si is right under carbon, and carbon likes to form 4 bonds, so silicon, Si, also likes to form 4 bonds. 1, 2, 3, 4, perfect. But just in case, we're going to count the valence electrons. Make sure everything adds up. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30, 32. It's 32. You can count. I can't count. But it's 32. So, since this doesn't violate the octet rule, and these don't violate the octet rule because it's 2, 4, 6, 8 on the silicon, then this one is not the right answer. It's just a normal one. Boo-hoo. Next one we do is, whoop, my screen went fuzzy. That's not good. C4. CF4. So we literally just said that carbon is under silicon, so it's going to do the same thing. So it's going to follow the same things as silicon. So carbon likes to form 4 bonds. Fluorine likes to form 4 bonds. It's going to have the same valence electrons because carbon and silicon have the same valence electrons. It's going to be 4 plus 7 times 8. So we're going to get, or not 7 times 8, 7 times 4. So we're going to get 32 again. So this is just the same thing, except instead of silicon, it's carbon in the middle. So we know that doesn't violate the octet rule. Cool. I don't have to say more because we just did this. Yay us. Cool. So next is the answer. So I'm going to prove that NF3 is also not violating the octet rule. N, F, F, F. So fluorine can only form 1 bond. So that means for nitrogen to have a full octet, it has to have these 2. So also, nitrogen has 5 valence electrons, plus fluorine has 3 times 7, so that's going to be 26. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 26. 26. So this is correct. No octet rule is violated, and also this works out because nitrogen likes to form 3 bonds and fluorine likes to form 1. So this doesn't violate the octet rule. Also, as a hint, if it's in that first row right there, so if it's hydrogen, lithium, Be, B, C, N, O, or F, these cannot violate the octet rule because they don't have the d orbitals to violate the octet rule. So this immediately eliminates, if you get a question like this on the test, which you might, this immediately eliminates both CF4 and NF3. Okay? But I also just proved it to you. So now let's prove that SEF4 isn't going to work out like we thought. So we have SE, SE, and then F, 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 F. So this is the most number of bonds that SE can form because fluorine can only form 1 bond. Anyway, let's do some calculations. I don't know where SE is off the top of my head. Oh, it's in the same row as oxygen. So that means it has 6 valence electrons plus 4 times 7, or 7 times 4, sorry. So 6 plus 28 equals 34, pretty sure. I think you can do math. Anyway, so if we count the valence electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 20. It's only 32. So we have to put 2 more on this SE. So that's why it violates the octet rule, because it has 10 electrons on this. 2, 4, 6, 8, 10. That's why this is your answer. Also, we can prove that this has this extra pair on it through math, because we have a lone pair formula. Woo! So, this could be the number of valence electrons minus then 8 times the number of atoms that isn't the center atom, so 8 times, and but for this case it's going to be 4, all over 2. So lone pair equals number of valence electrons, 34 times minus 8 times, there's 4, over 2. So this is going to be 34 minus 32 over 2, which is 2 over 2, which is 1 lone pair. So we have this one lone pair, so that proves it. Anyway, if you want me to do, that's 20. So if you have any questions, email me. If you don't like how I explained it, leave a hate comment. Boost my algorithm. I'm just kidding. No one's gonna watch these except for Chem. Except for y'all. Bye. If I can find the stop button.